In this video we're going to look at the general polar form of a complex number. Before I do that, I will just look at the forms we looked at so far. We looked at a rectangular form or Cartesian form. Two different names for the same thing. That's always in the form a plus bi. So for example, here's a complex number 3 plus 2i. I go to 3 on the real axis, I go up to 2 on the imaginary, and there it is. There's my complex number. Polar form. The way I think of this is, well, the form I have it in is r plus cos theta, r multiplied by cos theta plus I sine theta. And the way I think of that is, if the complex number is here, I look and see how far it is from the origin, and then the angle it makes with the positive real axis. So in this case, we have a complex number 5 away from the origin, and it makes a 45-degree angle with the positive real axis, or in radian form, pi over 4 radians. So in this case, right, I will put 5 in for my radius, and theta would be 45 degrees. So it's 5 multiplied by cos 45 degrees plus I sine 45 degrees. If I want to talk about it in radians, it's 5 cos pi over 4 plus I sine pi over 4. That's in polar form. In general polar form then, very much like polar form, except if you notice, instead of writing in just theta here, we add 2n pi, or if we're looking at it in degrees, we add n 360 degrees to theta. Why do I do that? Okay, let's have a look. Here's my complex number, right, and there it is. So how I would explain that complex number in polar form is it's 5 away from the origin, and in this case it makes a 45-degree angle with the positive real axis. Okay, just like in polar form. However, think of it this way. Let's say I'm looking at this complex number here again. 5 away from the real axis, grand. Now let's look at the angle it makes, 45 degrees. So if I go 5 away from the origin, and then 45 degrees from the real axis, I would get to here, where the complex number is. But what if I went 45 degrees up, and then I decided to go around another 360? I would get back to that very same point, that very same complex number. What if I decided to go 45 degrees, so I got to that complex number, and then I decided to go around another 360, and then another 360? I could actually go to that complex number and go around 360 degrees as many times as I want. Hence why we add in 360 degrees. And however many times I want to go around 360 degrees, I put in that number for n. Okay? So in this instance, I'll write this number, complex number, in polar form. So it's r, which is 5, cos theta is 45 degrees, plus 360 degrees, n 360 degrees, plus I sine 45 degrees plus n 360 degrees. And now, however many times I want to go around, I just put in for n. So if I want to go 45 degrees up here and then around another 360, I will just put in 1n for n. Okay? That's if we're looking at it in degrees. If I'm looking at it in radians, the same principle applies. Cos 45 degrees in radians is pi over 4. And 360 degrees in radians, 360 degrees in radians is 2 pi radians. And the way we write it is 2n pi. We could say, if you wanted, it's no difference, n 2 pi, if you wanted, okay? But generally we say 2n pi plus I sine pi over 4 plus 2n pi. So for and again, however many times we want to go around, we just substitute these n's with that amount of times that we decide to go to this complex number and then go around. Okay, if I got to this complex number, so if I went 45 degrees up and I got to the complex number and I decided to go around 360 degrees, I would still end up back at this complex number. Okay, if I did that, I put in 100 for n, but it would still be taking me back to the same complex number. Okay, I hope that makes sense. Thanks.